Welcome to the magnesium and hydrochloric acid mole ratio lab. You guys have been studying moles a lot lately, and we're going to try to prove that you should make a certain amount of hydrogen gas by mixing hydrochloric acid, concentrated hydrochloric acid, and pure magnesium. Now, it's concentrated, which means that its high molarity is a limit. So 12M means 12 moles of HCl's, or 12 times Avogadro's number of HCl's for every liter of solution, or every liter of acid. Let me show you how to do it. I took my magnesium and I put it on a scale, and I found that its mass was 0.066 grams. Of course, find the mass of your own magnesium. These were all cut by lab assistants last week, and so they all should be within 4 to 5 centimeters. The reason that's important is because later on we're going to calculate a percent error here in this box. And so we'll need a true measurement and a true value and a measured value. And my lab assistant was amazingly precise here and cut a 5.00 centimeter piece of magnesium. 5.00 centimeters. That's convenient because down here I have a ratio of length to mass for the magnesium strips that I'm using. All of the magnesium comes in these coils, and their masses per 100 centimeters we find by cutting a few different 100.00 centimeter lengths and then putting that coil on a scale. And from that ratio, we can compare a calculated mass to the scale mass and find out, well, how wrong is our scale? All right, from that length calculation, and then using the length to mass ratio given from the long coil of magnesium, I can get the mass that the 5.00 centimeter magnesium length, the mass it should be. That's our true value. Our measured value is up here. And we're going to try to see, well, how wrong is the 3 decimal scale compared to the 5 decimal scale that I got this value from. Now for more of the fun part. You'll have some copper chore boy. The copper doesn't react fast enough with the hydrochloric acid for this reaction, but the magnesium does. So we're using the copper to wrap the magnesium. So you make a nest for the magnesium, wrap the copper around it, roll it into a ball, and you shouldn't be able to see the magnesium in there. It should be buried inside. I'll show you what to do with this. Take your 400 milliliter beaker and fill it about 80% to the top. That's going to vary for a lot of you, but if you want to know exactly how much, you want to be able to take your graduated cylinder with your finger over the top of it and be able to fit your finger and the top of your graduated cylinder into the top and reach the top of the water and remove your finger. Like, do that test first to make sure you have enough water in your beaker. The next thing to do is use a Thumbwheel Pipette. If you've never used a Thumbwheel Pipette, that's the Thumbwheel. And with the Thumbwheel rolling upwards, you can depress the plunger all the way down to the bottom. And that's where you want it before you put the tip of the pipette into the concentrated hydrochloric acid. We want you guys to retrieve 6 milliliters of concentrated hydrochloric. And you'll notice that the pipette numbers go backwards. So 6 milliliters, 1, 2, 3, 4, 5, 6, is actually the number 4 on the pipette. So to fill the pipette, you need to roll your thumb down and the plunger will roll up and your pipette will fill. Fill it until the 4 millimeter mark. Make sure that that meniscus or the dish of the acid is sitting right on the 4. Move that carefully over to your graduated cylinder. And this is where you hit the plunger, or the release button. I already used the word plunger. Hit that release button, and your 6.00 milliliters should drain into the bottom of your graduated cylinder. Okay, so your next step is to push anything else out of the pipette. Push the rest of that acid out by rolling the thumb wheel back up. Replace the pipette into the cylinder next to the reservoir and put the glass, watch glass, back on. Now if you spilled anything, use the baking soda to neutralize the acid. For the next step, you want to fill with the acid at the bottom. You want to fill this graduated cylinder all the way up to the tippy top. And we've given you more acid than you need today. So make sure, it's okay if you spill a tiny little bit, but try to get that dish of water on the top. This next part you're going to want to do in sequence, so I'm going to try to do one continuous shot. You've got your copper chore boy with your magnesium inside, and you're going to push that into the top of your graduated cylinder. Then you're going to take your stopper, push that in as well. Nice and snug, but don't pound it. Then you're going to cover that hole, mix it a few times, and then place it into, now you can remove your finger once you've placed it into your beaker. The instant it's in there, this is the hard part. Air snuck in there. You can see that I'm making hydrogen gas, or what we suspect to be hydrogen gas. And you roll the numbers around, and it looks like about 3 milliliters. I'm going to say 3.0 milliliters. I'll mark the spot. That is the air that snuck in. That's going to contribute to my error later. So we've got some more information. Again, this is my data. Don't write this on your lab. You'll have your own data. But the magnesium mass, the calculated true value, is right here. The volume of the 12 molar, I put in 6.00 milliliters. Volume of air accidentally caught in the cylinder, that was later is going to contribute to my error. That's to the best of my ability. Volume of the reaction gas produced, that's what we're waiting on right now. It looks like I erred on the side of too much water in my beaker, and that's perfectly fine, and you can too. I'm overflowing as the hydrogen gas that I'm producing is displacing the water in the graduated cylinder. It's pushing that water down and back into the beaker. So just grab some paper towel. The acid is so diluted at this point, don't worry about baking soda unless you think you've spilled the undiluted concentrated hydrochloric acid. Put some paper towel around your beaker if it's overflowing, and just wait for the graduated cylinder to fill with gas until the reaction is over. The reaction's slowed down, it's almost stopped. It's good enough for this demonstration. I'm gonna take a measurement now of the amount of hydrogen gas that I have made. this is tricky because the graduated cylinder is upside down. So 50, 60, 61, 62, and you have to read the meniscus oppositely as well. So I've got 1, 2, 3, 63.5. And that 63.5 I'd write right here, 63.5 milliliters, and I think that it's H2, and we can test that next. All right. Right now, you have all the data that you need from the experiment except for proving that it's hydrogen gas. I'll show you how to do this final test, and then the rest of this lab is answering questions and doing calculations. Let's start with the removal of the graduated cylinder. You've already taken your final measurement, and so you can drain everything back in, but this is really key. Hydrogen is less dense than air, and so you want to make sure that your graduated cylinder stays upside down. If your graduated cylinder goes right side up, all your hydrogen will escape into the atmosphere. Bring your graduated cylinder over to your Bunsen burner and put your hand over your heart. Repeat after me. I promise I won't hold the plastic graduated cylinder in the flame. Because it will melt. All right, thank you. So quickly pass the graduated cylinder over the flame. And if you hear a bark, then that's a positive test for hydrogen. Now you can set your graduated cylinder down, record that you have a positive result for hydrogen, and move on to the calculations. Have a great lab.